three use cases. The first is supporting your knowledge workers across the WAN, so the wide area network, long latencies, branch offices. The second thing I want to do, Steve, is talk about supporting your knowledge workers across the LAN. So corporate environments, one building, replacing your PCs with a thin client. The third thing I want to talk about is demonstrate supporting your highest level designers, guys who need 3D graphics or CAD CAM designs. We're going to show that using PC or IP with hardware-assisted technology. So the first thing I want to do is talk about the WAN. So the WAN is actually a really tricky use case, but a very popular use case for VDI users. It's remote offices, it's branch offices, it's supporting folks from Bangalore to London, from New York to Palo Alto. So LAN characteristics are, you want a productive work desktop, meaning basic office applications have to work. PowerPoint, Excel, that needs to work. The plan here is with our software implementation of PC or IP, will support WAN use cases with 150 milliseconds to 250 milliseconds of latency. So that's going to be pretty good, a crisp user experience. But it's not just office applications. You need your web applications to work as well. So basic Flash videos, embedded Flash on your website, and web browsing needs to work in a WAN use case. But on top of that, you also want remote devices, Steve. Specifically, we'll support voice over IP, remote printers, or remote storage. So all of a sudden, if you're an enterprise that has branch offices, remote workers, telecommuters, offshore workers, and you want to centralize all that data to your data center in your corporate headquarters, PC or IP will support that with a software implementation of that protocol.
Very cool. Let's go to the LAN then.
So the LAN use case, which is actually more common, is replacing your desktops or transforming your desktops into a service. So centralizing all that data, all that information into your data center on a virtual data center OS, presenting a desktop to a thin client or PC. So the main difference between the LAN and the WAN, Steve, is bandwidth, right? You have better quality networks, fatter pipes going to your desktops. So we're supporting multiple displays across the LAN. Each display will support resolutions of 1920 by 1200. So that's going to be pretty good. But on top of that, not only will we get multiple displays, all the features of the WAN protocol, Steve, you're also going to get rich internet applications. So Flash videos, Silverlight, Adobe Air, all that's going to work crisply across the network. Nextly, you're going to get a true PC experience because high-definition video, high-definition audio will also work across the LAN. So HT video, streaming audio, streaming video will work across the LAN. So it's going to look like a regular PC. And finally, across the LAN with PC or IP, you'll get rich 2D graphics and animation. Again, this is all the software implementation of PC or IP.
Yeah, what about if we want some 3D graphics? Is there any hope on the network side?
So 3D graphics has always been a tricky problem for VDI users, or remote display protocol users. With PC or IP, the same protocol we're using for the WAN and the LAN is going to be intelligent enough to take advantage of hardware-assisted technology to render 3D graphics. So VMWorld, the product we described earlier, will have the ability today to broker thin clients to remote rack workstations. So what I want to display to you today, Steve, is a 3D animation from a thin client to a rack workstation backstage.
And this is brokered by VMware View.
This is brokered by VMware View. So what we have here is Google Earth, which requires a GPU and 3D animation. On stage, we have a simple thin client. So there's, if I had a cloth in front of me, I would say, magician, there's nothing underneath the table. But backstage, you have a rack workstation that's a quad-core processor, 2.5 gigahertz, with an NVIDIA Quadro GPU. So you're going to see now a great, rich 3D user experience across the LAN. So let's go here. So this is Khan, and here's the Palais. So we can kind of zoom in quickly, zoom out. And you can notice, Steve, that it's smooth. There's no choppiness, no jaggedness whatsoever. But that's Khan, and we've been here for 4 or 5 days. So this weekend, I'm actually going to plan to take a couple days off and fly to Paris and visit it. So let's kind of plot what it will look like if we fly from Cannes all the way to Paris, about 1,000 kilometers. So if you notice the animation is crisp, there's no jagged edges, there's no start and stopping, and here we are in Paris, and this is the Eiffel Tower. So once again, we can zoom in, we can move it around. You notice like I'm doing this really quickly, and there's no kind of lag or latency. I can even spin around. And so you're really getting a true PC experience as if I had that quad-core workstation right here. But it's not. All I have is a thin client remoting to a rack workstation backstage. Now, so this is kind of nice. Get to see Paris from Google Earth. But let's say I'm a high-end developer or designer. I really want to know more about schematics of the Eiffel Tower. So I can switch over to 3D XML document. So this is actually a pretty complicated 3D XML document of the Eiffel Tower. It has tens of thousands of individual vertices that need to be rendered. So once again, I can scroll this around. I can zoom in or zoom out. And this could be any kind of a 3D CAD/CAM design. So it could be AutoCAD, it could be another 3D XML, but the inside engineer may just want to spend all the time and kind of play around and be a tourist around the Eiffel Tower. You need to go there in person. But there you have it. You have a 3D implementation using hardware-assisted PCRIP. So in summary, PCRIP will support great use case around the LAN and the WAN with a software implementation. And for your most demanding users with 3D demands, we'll use hardware-assisted technology from our partners at TerraDigi, powering the rack workstation to this thing client.
Fantastic. Thanks, Jerry.